October 21st, 2025. Just as Atlas was approaching its closest point to the Sun, the Earth fell into an unexpected silence. Every telescope aimed at the Sun went blind at the same moment. For 6 weeks, no observation instrument functioned. The reason was simple. The Sun's brightness made all space observations impossible. This was not merely a technical inconvenience for a few astronomers. It meant that, at the most critical moment concerning the third interstellar visitor ever observed by humanity, the universe had effectively drawn its curtain closed. And ironically, this period of darkness provided the perfect window for something that might wish to remain hidden. Just as the countdown began, a development shocked scientists. A small but meaningful deviation was detected in Atlas's trajectory. This deviation sent shockwaves through the scientific community. Measurements from the James Webb Space Telescope revealed an unexpected chemical ratio. The concentration of carbon dioxide and water within Atlas was 8 times higher than in any known comet. During its close pass by Mars, analyses showed a clear asymmetry on its surface. Nickel mapping from Japan's KK Observatory pointed to a chemical composition rarely found in nature. These findings led scientists to one unsettling question. What were we missing during those 6 weeks of blindness? And when observations resumed in December, would the picture before us belong to known physics or to something entirely different? The cause of the darkness was simple, yet unavoidable: solar geometry. From Earth's perspective, Atlas passed directly behind the Sun. This rendered optical, infrared, and radar observations completely useless. It wasn't a malfunction, nor a bureaucratic delay. It was a matter of pure physics. On October 21st, the alignment was complete. The new moon phase, full solar overlap, and the comet's approach to perihelion, 8 days away, meant the sky was effectively unobservable. For 6 weeks, no telescope could focus on that region. The Sun's intense radiation acted like an invisible wall, suppressing every signal. The angular distance between Atlas and the Sun fell below 1 degree, narrower than twice the Sun's apparent width. Signals from Atlas vanished completely within the Sun's millions-degree plasma layer. Observing it from that distance would be like trying to detect a candle flame behind a stadium floodlight. Even radar systems failed as the Sun's magnetic field, filled with charged particles, disrupted all consistent data. Scientists knew this timeline by heart. October 21st, the observation. Blackout begins, October 29th, perihelion, the period of maximum heating. Normally, this would be the moment when a comet reveals its secrets, jets of gas and dust erupting from its surface. But this time the world could see nothing. No images, no reflections, no spectra, only silence from Atlas. And therein lay the true significance. If the object were to alter its trajectory, lose a fragment, or exhibit anomalous motion, it would happen precisely during this period of invisibility. This wasn't just a lack of data, it was a test of scientific faith, a trial of our trust in models, physical laws, and observation. When Atlas emerged from behind the Sun in December, every theory, every prediction, every data point would have to be re-evaluated. Until then, time would continue to flow, and the sky would remain dark. But before continuing, think about this. What if we are not alone? While we search for answers, don't forget to subscribe, like the video, and share your thoughts with us. Just before the darkness began, observatories around the world raced against time. The goal was simple: to understand why Atlas was behaving so differently. The first major observation came from the James Webb Space Telescope. Dr. Melissa Cheng and her team submitted an emergency request to observe Atlas on September 18th. The resulting infrared spectrum sent shockwaves through the scientific community. The ratio of carbon dioxide to water vapor in Atlas was 8:1, not a typo. Normally, water dominates in comets, with carbon compounds being minor components. But in Atlas, this balance was completely reversed. Statistically, the deviation was at a 6 sigma level. The chance of it being random was nearly 0. James Webb's data also revealed strong carbon dioxide lines, moderate carbon monoxide, and traces of carbonyl sulfide. Isotope ratios were consistent with solar system materials, but the overall chemistry matched no known comet pattern. The results sparked intense debate within NASA. Some administrators argued for withholding the data until it could be verified, but Dr. Jung and his team insisted that missing Atlas's perihelion would be a monumental loss. Observations were eventually approved, but the data had already planted a question in everyone's mind. Was Atlas truly a comet, or something else entirely? Meanwhile, Japan's KK Observatory had been collecting data throughout August and September. Spectroscopic maps revealed an unusual concentration of nickel surrounding Atlas. Iron emission lines were weak, while nickel lines shone strongly, suggesting that gas emissions were not random but organized. Gas and dust from Atlas formed a narrow outflow toward the Sun. One side of the object was active, the other almost inert. Some researchers tried to attribute the imbalance to measurement error, but reprocessed data confirmed the pattern. There was no software glitch, calibration fault, or optical artifact. The readings were real. Nickel was abundant, iron was scarce, and chemical distribution was asymmetric. Images showed Atlas's coma, its surrounding dust and gas cloud, extending nearly 6 radii outward. Mass loss was about 150 kilograms per second, with water production only 40 kilograms per second. This indicated that the object's energy came primarily from carbon-based compounds, not water vapor. Hubble's July images confirmed the picture. The comet was surrounded by a smooth, teardrop-shaped halo of gas. Edges were soft, no jets or outbursts were visible, only a steady glow. Such stability was extremely rare among solar system comets. The core itself remained unseen, but early images from the Rubin Observatory on June 21st allowed scientists to estimate its size, about 5 to 6 kilometers in diameter, rotating very slowly, with minimal brightness variation, a cold, calm, massive interstellar traveler. On September 27th, Atlas passed just outside Mars's orbit, a golden opportunity for both ESA and NASA. For the first time, an interstellar object passed so close to a planet under active observation. ESA's Mars Express and Trace Gas Orbiter began collecting data, and results were startling. For about 17 minutes after the flyby, Mars's atmosphere showed a sudden increase in ionization, as if a wave had struck the planet's ionosphere. The effect was too brief to be caused by any solar flare, and the sun was quiet at the time. Thus, the disturbance likely came from Atlas. Ionization wasn't localized. It extended along nearly the entire Martian equator. ESA engineers called it a temporary electromagnetic echo, but its origin remained unknown. Hours later, Atlas's position data appeared in NASA's Deep Space Network logs. And then something strange happened. Tracking signals suddenly cut off, as if drowned out or jammed by an unknown frequency. The blackout lasted only minutes, but during that time NASA's servers were restricted. Most scientists dismissed it as a technical failure, yet the coincidence with Atlas's Mars alignment was suspicious. Internet users noticed quickly. NASA's live monitoring dashboards went offline. Neither NEOS, Mars probes, nor asteroid tracking networks were accessible. Everything stopped at once. 40 minutes later, systems came back, but historical data remained inaccessible. NASA released only a brief statement. Data transmission temporarily halted due to routine maintenance. Few believed it. There was no scheduled maintenance window at that time. Even ESA experienced a parallel outage, a near-simultaneous data blackout that made random failure nearly impossible. When the Mars ionization event and data cut were considered together, the picture grew more complex. Some researchers suggested that Atlas might not be a passive rock, but an active energy-emitting structure. Others proposed it had intense magnetic components causing natural emissions. But the central question persisted. If everything was natural, why were those data never released? ESA's final public report merely stated a transient ionization event was observed. Causal relationship undetermined buried in that single line was an immense silence. From that moment on, Atlas became the center of an information blackout. The data weren't lost, just hidden, and that invisibility lasted for months. ESA's final public report merely stated a transient ionization event was observed. Causal relationship undetermined buried in that single line was an immense silence. From that moment on, Atlas became the center of an information blackout. The data weren't lost, just hidden, and that invisibility lasted for months. After Atlas's Mars flyby, the scientific world fell eerily quiet. Neither NASA nor ESA made further statements. Media coverage vanished within hours. It was as if no one wanted to discuss what the object truly was. Yet amateur astronomers continued their work. Hundreds of observatories across Earth tracked Atlas as it moved away from Mars's alignment. Some telescopes recorded faint but rhythmic light pulses, too regular to be random reflections. But despite careful analysis, the frequencies were unstable, their meaning indecipherable. Many dismissed the signals as optical illusions. Yet independent teams at different sites reported the same results. The coincidence was hard to ignore. Around this time, NASA's scientific data portals went offline, allegedly for security and data integrity updates. But the timing was suspicious. Exactly 3 days after Atlas's Mars encounter, not during it. Some former NASA employees posted cryptic social media messages about unusual energy signatures. Before those posts were quickly removed, reportedly manually, not algorithmically. Meanwhile, ESA prepared standard public assurance statements for emergencies, but this time drafts were halted before release. Staff were reportedly warned that publishing the data might violate international data sharing agreements. The only publicly released detail was a slight trajectory deviation, small but significant, since an interstellar object altering course within the solar system defied known physics. Some theorists proposed that Atlas contained a magnetic propulsion-like mechanism, a claim no agency confirmed, but one that grew louder as silence deepened. At that point, the situation turned almost political. Independent researchers seeking data were denied access on international security grounds. The mystery had shifted from scientific to strategic. Journalists claimed Atlas-related data were stored in a shared repository, accessible only to select institutions, but no one outside had seen the contents. As time passed, curiosity turned to suspicion. Atlas faded from headlines and entered whispers, and with each passing day the question grew louder. Was something being hidden? After passing Mars, Atlas turned toward the Sun. At first this seemed a normal orbital path, but soon it became clear it wasn't decelerating. It maintained its momentum, suggesting active propulsion or energy conservation. Ground-based telescope networks reactivated. One northern SAA station recorded wave-like surface oscillations on Atlas, not explosive bursts, but rhythmic pulses, as though some internal mechanism was at work. Initial analyses blamed thermal stress or gas jets, but spectral data contradicted that. The wave pattern was too stable to occur naturally. At the same time, amateur observers began reporting a greenish glow surrounding Atlas. Not a typical solar reflection, but a faint energy ring shifting orientation between frames. NASA's SOHO Solar Observatory captured several images of Atlas's approach, but most were later removed from public databases, replaced with only a few low-resolution frames. Even those showed faint ionization traces around the object, effects typically associated with strong electromagnetic fields. A leaked internal ESA report contained one striking line: Atlas exhibits anomalously high energy density. The observed plasma emission is inconsistent with known cometary behavior. The phrase plasma emission implied active energy production, and if true, Atlas might not be an inert interstellar rock, but an energetic structure, perhaps even an engineered one. Officially, ESA downplayed it. Atlas displays a natural ionic tail, not unusual for comets. But this contradicted earlier data. Leaked emails showed that key terms in reports had been deliberately altered, energy density replaced with reflection anomaly. Many began to suspect deliberate obfuscation. Atlas's true nature, it seemed, was being concealed. Yet the cosmos was indifferent to secrecy. As Atlas drew closer to the Sun, its trail became impossible to hide. By late October, Atlas had passed completely behind the Sun, initiating 6 full weeks of total observational silence. No optical, radar, infrared, or thermal system could see it. The Sun's blinding light suppressed all signals. During this invisible period, no one knew what might be happening, but its importance was immense. Any trajectory shift, gas eruption, or fragmentation would go unnoticed. NASA and ESA released limited retrospective data based only on earlier measurements. The critical 6-week gap was left blank. Some scientists saw this as simple geometry. Others believed Atlas possessed an active internal mechanism allowing controlled motion, something no known comet could do. This 6-week darkness became a test of instruments, models, and human patience. For when Atlas finally re-emerged in December, every prediction would stand or fall. When December arrived, Atlas finally emerged from behind the Sun. The 6 weeks of silence were over, and observatories around the world were ready. Telescopes, the James Webb, Hubble, the Rubin Observatory, and ESA's Mars probes all focused on a single point. Initial results were electrifying. Atlas had shown only minor trajectory deviations, small enough to be explained by natural outgassing, yet subtle enough to suggest something more. Spectroscopic data confirmed earlier anomalies. Carbon dioxide levels remained abnormally high, nickel-dominated, and the coma maintained its teardrop form. The same anomalies observed in Chapter 6 persisted. Atlas was still extraordinary. All combined data revealed that during those 6 weeks of invisibility, Atlas experienced no major disruption, but may have made a slight, perhaps deliberate, course adjustment. This hinted that Atlas was not a passive interstellar stone, but an active and enigmatic structure. 2 scenarios remained. 1. Natural scenario. Atlas is an exceptional interstellar comet, whose unusual carbon dioxide and nickel content reflect a unique chemical history from beyond our solar system. 2. Anomalous scenario. Atlas possesses internal mechanisms allowing subtle trajectory control, concealing its actions during the 6-week blackout. If true, this would mark the first observation of a phenomenon beyond natural physical laws. Either way, the December observations were a turning point. The silence had not merely been a loss of data. It was a trial of science itself, a moment when physics, astronomy, and human curiosity were tested. Every observation, every measurement, every pixel became crucial to understanding the object's nature. This experience taught a humbling lesson. The universe hides its secrets through geometry and timing. But with the right tools, patience, and precision, those secrets can be unveiled. Is Atlas a mystery, or simply a rare comet? More data is needed to say for sure. But one thing is certain: observation and precision will always prevail.